So we're now going to determine the relationship between two lines. So what we want to know if the lines are going to be parallel, perpendicular, the same line, or intersecting lines. Okay. So now I could graph these and see, right? I could even graph them in Desmos and see, but I can also just look at the slopes and decide. So for example, in number 1, the slope here is 3/4, and the slope here is -4/3. What's the relationship between those slopes? I notice those are opposite or negative reciprocals. So because they're opposite or negative reciprocals, I know that if I graph these lines, they're going to be perpendicular. Okay, let's take a look at number 2. Number 2 is not so simple because these lines, I can't see the slope as clearly, right? So what I'm going to do is I'm going to go ahead and rearrange both of these equations into slope-intercept form so I can see the slope clearly, and then I'll be able to compare the slopes. So here, remember with slope-intercept form, I want y by itself. So here's the y. I'm just going to add 5x to both sides. And I get y equals 5x plus 7, and my slope is right here, right? That's 5. And then here I notice, oh, I got to distribute first and then add that 2. So it's 5x plus 5, and I add 2. And here I notice they have the same slope. So you might be tempted to say, oh, these are parallel. But what I also notice is, look, they also have the same y-intercept. So these lines aren't parallel. This is literally just two different ways of expressing the same line. Okay, so these two equations are the same line. Okay, they're not parallel. They're the same. These two lines will lie right on top of each other. Now, here, I notice my slopes are already visible. I can see my slope is 1/3 and 3. Now careful, you might be tempted to say, oh, those are opposite reciprocals, they're perpendicular. But they're not. These are reciprocals, but they are not opposite reciprocals. Notice that they're both positive. In order to be opposite reciprocals, right, they have to be reciprocals, and one's positive and one's negative. So these are not perpendicular. Okay, these are just two lines that intersect, right? If I were to graph these on a graph, I would have something like this, would be that first line, right? 1/3 x plus 1, and then 3x plus 6 would look something like this, right? But notice those are not intersecting at a right angle. They're not perpendicular. So these are just intersecting lines, just two regular old lines. They're not parallel, so they will intersect, right? Parallel lines don't intersect. They're not perpendicular either. They don't intersect at a right angle. How about these? Y equals 7 and x equals -5. Let's just sketch these on a graph. Remember, x equals -5 looks like this. It's a vertical line, right? And the slope of that vertical line is undefined. And y equals 7 looks something like this. Okay, the slope of that line is 0. And we can see that these intersect at a right angle, and these are perpendicular. Okay, your turn to try. Okay, I want to know, in each set, are these lines parallel, perpendicular, the same line, or none of those, and they're just two regular intersecting lines?